Okay, what I see when I look around here is quite good, so I don't see function notation being a problem. I see distributive law errors, you know, superstition, and other things that we want to try to avoid, okay? It's not what it looks like, it's what it is, and what it is in all three of these cases involves a distributive law, okay? No distributive law, well, you actually do have a distributive law here too, okay? So everybody got f of -2, except let's be careful. There's something wrong with something that I saw in at least one paper. What's wrong with what I just wrote there?
Parentheses.
I'm sorry?
Parentheses.
Well, there are no parentheses. Oh, are these parentheses wrong?
No, the other side. You got to put some in there.
Well, there aren't any parentheses, so how could parentheses be wrong if there aren't
You got
any?
to put some in there.
Oh, you mean there should be parentheses?
Yeah.
Why? Because you're squaring the -2, and this doesn't mean square -2, does it?
That means square root.
As we explained last time, this means square 2 and then take its negative, right? And that's one. That's a pitfall. Very common. I fell into it a few times. That was back when they could, you know, beat us for things like that, so I got out of the habit fairly quickly. Okay. You know, things were rough back then. You had to be tough. Okay. Oh, how did I ever get through it? Okay, well, anyhow, you get 4, right?
Yeah.
So you just want to be careful. I just wanted to make sure and emphasize, write things down carefully and correctly. Okay? Okay? Now how do you square x plus 7?
Distributive law.
Distributive law. Now you do have a special product that you're probably used to. You know, like x squared plus 2a plus a squared, right?
Mm-hmm.
Where does that come from? No, it was handed down on a stone tablet to the first mathematician by, I don't know, Zeus or somebody. Okay? Right? That's my story.
I'm
Yeah.
so sorry. I just wanted to pick up those thank you notes that they wrote the other day.
Yes, I have them right here. Okay. Okay?
Yeah.
There's a special product, but if you use that special product, you should be using it by saying, okay, x plus a times x plus a is x times x plus x times a plus a times x plus a times a, and that comes out x squared plus 2a plus a squared, right? 2ax plus a squared. Okay? And you should always be able to do that instantaneously if you're going to use that formula, because that one is pretty simple. Anyhow, that's x plus 7 times x plus 7. Fill in the details, you get x squared plus 14x plus 49, right? You don't want to make mistakes. So I want you to use the distributive law every time it occurs because you need to get in the habit. Okay? Doesn't mean you can't use a special product, especially if you're factoring. Most of you used it when you did that impressive factoring on the second day with the discriminant of that R, 1 minus S, 1 minus RS matrix, right? With the lambda in it. Okay? It's quite good. But always know where those things come from. Okay? And that's the beginning of the explanation of that picture up there. But I'll give you the whole explanation later, and then at some point when you are ready to totally understand what that picture says and does, I'll give everybody a copy. It's really pretty good. I ran into the person that did that at the farmer's market. Told her somebody's asking about it. She was delighted. Okay, so That's what we have, okay?
Yeah.
Now, when you get to f of x plus delta x, well, if you knew what to do with x plus 7, you know what to do with this, right?
Mm-hmm.
Now, one thing I get, though, a lot of times is, well, that's x squared plus delta x, because you got a plus delta x there, right? That's not how function notation works, but that's what I see a lot of, including on assessments of people who've completed pre-calculus courses, okay? Again, that's not because it's poorly taught. I think it's well taught everywhere it is taught. It's just due to the fact that it's being taught to too many students, I think, who aren't ready for it. Okay. Anyhow, that equals, I'm not going to write out the details, you know what that is. That's going to be x squared plus 2x delta x plus the square of delta x. And it's probably best to put that in parentheses so you know you're not doing the delta of x squared, right? Okay? Although sometimes I'll write it out without the parentheses and use the convention that if I want the delta of x squared, I put the parentheses around the x squared and the delta in front. That would arise like in the change in 1/2 rho v squared. Okay? So it's a perfect example. Well, then you can go on with this and simplify it and so forth. Anybody tell me in terms of the graph what this means?
Graph.
Why would that be the definition of a derivative? But if you take the limit as the delta x goes to 0, that's exactly what it is. What's a derivative? Huh?
I'm ready.
I mean, it's very good that you know this.
Isn't it
Okay, I'm impressed, but
Is it the equation you get when you put in a point, and it's the equation of, there's the slope of that line at that one tangent point or something?
yeah, that's very good. Okay, and what is a slope?
Change line.
It's a rate of change. So derivative is an instantaneous rate of change, which is very relevant to a lot of what you did for homework and will do for homework, right? Also to that bullet falling and all kinds of things, okay? Now, not everybody knows that, okay? So all I'm going to say is that's just the average slope on the interval from x to x plus delta x. That's average slope. And I can draw a picture, but it's lunchtime, you know, done this much, and I'm very impressed with what you're able to do with this, okay? So everybody is in shape to understand this. Just be careful about the distributive law and other rules of algebra, right?
Mm-hmm.
Because we can apply this now to an exponential function, a power function, except you can't apply it to a power function until you understand a little bit of statistics and permutations and combinations and Pascal's triangle and be able to extend that to irrational numbers. Well, we're not going to get that far with it, okay? But you kind of need that to get the derivative of a power function. A quadratic function's real easy, and we'll be able to do all that. To the extent that we can use your quadratic model in the two areas of the container and the tube to predict your linear model for the horizontal range. Okay? And if you know how to do that, you know more calculus than most calculus students do at the end of the course. Except maybe you don't know all the details of the manipulations. Okay? Most people get to the end of the course and couldn't even begin to address that question, and that's one of the touchstones I'm going to give you for a calculus course. At a certain point, in about the first month to 6 weeks of your calculus course, you should totally understand that model in all its glorious detail. Okay? And I think you will. Okay, very good.